Hi, this is Dr. S and welcome to video 9 of my series on aromatic chemistry for OCR A-level. In this video I'm concentrating on alkylation and acylation reactions. So alkylation would be where we are putting carbon chains directly onto benzenes to form something like methylbenzene, and acylation is where we put carbonyl groups right next to the benzene such as this to form something like phenylethanone. Now these are critical reactions in organic chemistry because it allows us to put carbon-carbon bonds directly onto an aromatic ring. So it's useful in hundreds, thousands, millions of organic reactions. Now the foundational work for this was done in the 1870s by two scientists called Friedel and Crafts. So these are now known as Friedel-Crafts reactions. So that is what we'll concentrate on in this video, is the Friedel-Crafts reactions to form methylbenzene and phenylethanone. I'll also give you a chance to try and apply the knowledge that you've brought together over the last few videos to practice doing these mechanisms in unfamiliar circumstances, which is what top grade students would do in the exams. So let's look at the reaction of benzene to form methylbenzene. Now in order to do that, I actually react it with a haloalkane. So in this case I'm going to use chloromethane. That then produces HCl as a byproduct. Now, as you've probably come to expect, this is not going to cut it on its own. We need to make a more reactive electrophile from this in order to react it with the benzene. So we're going to back to using halogen carriers. In this case I'm going to use aluminium chloride. The aluminium chloride will steal this chlorine here to make my AlCl4- ion, and it will leave the CH3 with a positive charge. So almost like a methyl ion. Very, very reactive. So when that comes close to the benzene, it will react with it. So I'm going to ask you to try and predict what the rest of the mechanism is. So how does the methyl ion react with the benzene? What's the intermediate? What's the final product? And also, how do we recreate the AlCl3 catalyst? There's still 5 marks to go at here. So pause the video, have a think, have a go, and then come back when you're ready. Okay, thank you. So what we should have is that we have our benzene with our methyl ion. Now technically the positive should be on the carbon because that's where the electron's missing from, but that's generally how we see it. A movement of electrons from the ring to there to create my intermediate. So in this case we have a hydrogen still attached and a methyl group. That's the carbon with 4 bonds, so it cannot take part in the delocalized system. So we have our horseshoe shape with a positive charge in the center. Then movement of the pair of electrons from this carbon to hydrogen bond back in to recreate the delocalized system and form methylbenzene and my H+ ion. That H+ ion has to go somewhere, so that reacts with the AlCl4- ion to recreate my AlCl3 halogen carrier and to form my HCl. Okay, hope you did well with that one. Now let's look at an acylation. So an acylation might be, again, to take my benzene and to create something like phenylethanone, like this. Now actually, what this will react with is something that you may not have seen yet. So this would be the structure of the compound that it reacts with. That's called ethanoyl chloride. Okay, you probably haven't seen that before, but you might have seen, or you should have seen, a carboxylic acid, and you might be able to see how it's related. Just to remind you, the carboxylic acid, ethanoic acid, would look like that. So you can almost imagine the OH being replaced by a Cl to form that. You will come across these type of compounds quite a lot in year 13. The general name for them are acyl chlorides. and they're not just used for reactions with aromatics. You'll see them several times. This is called ethanoyl chloride. So that would form my phenylethanone, and it would also create an HCl. So now what I'm going to ask you to do is try and think about how this reaction might occur. And this is difficult, so I'm going to leave you to pause the video again and have a think about what might happen. How am I going to create a more reactive electrophile from this? And then how is it going to react with the benzene? What's the intermediate going to look like? And how am I going to recreate a catalyst? So all 6 marks are available for you to go at. Have a think, pause the video, come back when you're ready. Okay, well done if you got anywhere near that. So the ethanoyl chloride is not quite reactive enough for the benzene. So just like on my previous reaction, I need to react it with a halogen carrier so that the chlorine is removed. That will leave me with this, a very reactive carbocation. That can now go quite close to the benzene. Now, if you didn't get this first step, it might be wise now to pause the video again, and now we know what the electrophile is, try and do the rest of the mechanism. I'm going to keep going. So that reacts with this. Now this will be quite a complicated curly arrow, but it'll go from the ring round to the carbon that's there, and it will form my intermediate. And again, just like all the others, we've got a hydrogen. But now if you look at what this has formed a bond to, it's formed a bond to this carbon here. So the carbon of the benzene ring is forming a bond to this carbon. If you look at this carbon, it has a double bond to an oxygen and another methyl group, so it forms that. That's the carbon with 4 bonds, can't take part in the delocalized system. So horseshoe shape with a positive charge. Now it's just the same. Curly arrow from the C to H bond back in. To create that, which I hope you can see is the same as this, just slightly turned 60 degrees. And then H+. And just like the previous one, the H+ can react with the AlCl4- to recreate the halogen carrier and to make an HCl. So hopefully I've shown you how similar these mechanisms are, and how practice and practice and practice can help you answer any electrophilic substitution question. In my next video, what I'll do is I'll bring in some unfamiliar electrophiles, some unfamiliar aromatic compounds, and see if we can apply all of the mechanisms that we've learnt over the last 3 videos. Okay, I look forward to it. I'll see you then.